Hey gang, today we're adding and subtracting terms with radicals. When adding or subtracting terms with radicals, only like radicals can be combined. Simplify by adding or subtracting the numbers in front of the radical and keep the common radical. Add or subtract the following and state whether the simplified answer is rational or irrational. All right, so you can think of a common radical as kind of like a variable. So if you have 1x and 3x together, you make 4x. If you have 5x's and 6x's together, you have 11x's. So if you have 2 square root 2's and 4 square root 2's together, you have 6 square root 2's. So you think of it the same way, only when adding and subtracting. So for number 1, we have common square roots across the board. So 8 square root 5 plus 1 more square root 5 is going to be 9 square root 5 minus 2 square root 5. And 9 square root 5 minus 2 square root 5 is going to be 7 square root 5. Final answer. And that, because we have a square root that is not a perfect square left over, is going to be irrational. Okay, number 2, we have 15 square root 2 minus 2 square root 98. Well, 15 square root 2 is as simple as it gets, but not 2 times square root 98 is not. So I have to figure out the perfect square factors of 98 to simplify this. So if I go to my y equals and do 98 divided by x and pull up the table, right away I see 198 and 2 and 49, 49 being a perfect square. So this is equal to 15 radical 2 minus 2 times 7 radical 2. 2 times 7 gets multiplied, so we get 15 radical 2 minus 14 radical 2. 15 minus 14 is 1, so my final answer is just square root or radical 2. And again, this is irrational because it is the square root of a non-perfect square. All right. Number 3, I have 2 square roots, neither of which are simplified. So square root of 27 would be 9 times 3. So this is 3 radical 3 because the square root of 9 is 3. Plus square root of 75 is 3 times 25. Square root 25, I get 5 square root 3. Now I have a common radical, so I can add 3 and 5 to get 8 square root 3 as my final answer. And again, this is irrational because I have a square root left over that cannot be simplified. So it is not a perfect square, making the final answer irrational. Same thing with number 4. I have to simplify first. So square root of 63 is 9 times 7. So that's 3 radical 7 minus square root of 28 is 4 times 7. So that's 2 radical 7. Subtracting 3 minus 2, I get 1. So my final answer is just square root 7. And again, this is irrational because I have the square root of a non-perfect square. And if I were to put it in my calculator, I would get a non-repeating, non-terminating decimal that would keep on going if I stretched out my computer screen. I wouldn't be able to turn it into a fraction, making it irrational. All right, let's continue. Number 5, same deal. I got to simplify these. So hopefully you recognize right away, 164 and 9 are all perfect squares. So square root of 100 is 10, minus square root of 64 is 8, plus the square root of 9 is 3. 10 minus 8 is 2, plus 3 is 5. So this is rational because it's a whole number. It's no radical left over, so I have a rational answer. And then number 6, I have to simplify again. Now, 180 is not a perfect square, and I don't really know the perfect square factor off the top of my head, so I'm going to go to y equals, do 180 divided by x, pull up my table, and look for a perfect square factor. So I get 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36. There's my perfect square. So this is square root 36 times 5, or 6 square root 5. Same thing with 80. Now, I know that it's probably going to be something with a 5 because I want a common radical. So I can pull up my table again and just do 18 divided by, or 80 rather, divided by x. And I match it up with 5, and look at that. Sure enough, 5 is with a perfect square of 16. So that's 16 square root 5, or 16 times 5 under the radical. The square root of 16 is 4, and I'm left with square root 5. 6 minus 4 is 2, and I'm left with the square root of 5. So this, again, is irrational because I'm left with a non-perfect square. All right, so you're going to try 7 through 12 on your own. Check in with me so I can make sure your answers are correct before moving on to your exit tickets.